Okay, today's lesson, basic inverse trig functions, is a fairly in-depth lesson. And so I need to do a lot of groundwork just to make sure we review and cover some basic ideas. So then I could make a point of why we do what we need to do for the actual lesson. So the beginning here is not quite the lesson yet, but building the idea. So let's just start with some basics here. If I am doing trigonometry, if I have an example like sine x, then here are just some things that what we need to know is like the components of this. Like, what does that x represent? What does this answer represent? I think is really key. So when you have sine x, that means you're plugging in an angle. So sine, and then there's always an angle plugged in. Now, what's a little challenging with that is that there's two ways of giving information about an angle. There's two different units. One is degrees and one is radians. But again, they're both just angle measurements, just different forms of that. To know which one you're dealing with, you'll see a little bubble right here if it's in degrees, and if there's no bubble, then that means you're working with radians. This problem has no bubble, so we're in radians. So you plug in an angle, and then out comes a ratio of sides. The ratio of sides of the triangle. In that, for sine, the ratio we know is opposite over hypotenuse. But of course, there's different ratios depending on which, if we're doing cosine or tangent or secant or cosecant, whatever. The ratio, as we know, a ratio is a fraction, and this fraction is always reduced. So it doesn't matter if you're dealing with a really tiny triangle or a really big triangle, the ratio for whatever angle of the opposite of our hypotenuse fraction, that ratio will reduce to the same amount every time. Okay, so this is the main idea of what trigonometry is all about: inputting an angle, outputting the ratio of the sides of the triangle. Okay, so now we kind of switched up some things in the last kind of lessons here, where this time, if you notice what's happening here is the x that we're trying to find is kind of backwards. Normally we'd be finding this component, the ratio of sides, and instead now we're finding this component, the angle here. So we're finding the angle in radians when the triangle has a ratio of sides 1 to 2. So which angle, there's only, there's a certain angle that creates that specific ratio. So what we did to find that is, we could do it a couple ways. We could actually draw the triangle and figure out like an opposite of 1, a hypotenuse of 2. And if that's a triangle, what angle would be here would be a 30-degree angle. 30 degrees would make 1 over 2, or as a radian would be pi over 6. So let's actually use degrees for this one. So I'm going to put a little bubble right there. So we're in degrees. So the answer here would be 30 degrees. So the answer to this problem would be x equals 30 degrees. But if we look at the unit circle, we know, or the quadrants, we know that sine would also be positive in the second quadrant. So a 30-degree angle, reference angle here, would be 1 to 2 as well. So that angle is not an answer of 30, but it's an answer of getting from here to here would be 100, and this would be 150 degrees right there. Then there's two answers to this problem. So two answers. But actually, there's many more because it says find all solutions here. You could technically get to this triangle right here by going 30 degrees or by going around 360 plus another 30. So I guess that would be 390. And you would get to this same triangle. Or whichever angle you want to get to, maybe this one over here, you could get to that by going 150. Or by going around 360 and then another 150. I could get to this triangle right here by going around 3 plus 360, plus 360, plus 360 as many times as I want. And I would still get in the second quadrant with the same exact ratio. So the answers here to make all solutions are really 30 degrees plus 360, and I would have another answer. But I can go around an additional 360, as many times as I want. And so I put an n there to say like how many times I want to go around. That would be an answer. And same for the 150. So it's really 360 times n, which this gives me an infinite amount of solutions here. Okay, let's take a look at another situation that is very similar to this, yet requires some different ideas to talk about. Now, here we have sine with a little -1 we read as a sine inverse. What happens when you do an inverse is you switch the x's and the y's. So the two pieces here switch spots, and you put a little -1 there to say it's the inverse. Well, that means that this is the ratio of sides, and the answer that we're looking for is the angle. And let's use, I'm going to put a little bubble there. Let's say the angle's in degrees. Oh, shoot, I put radians here. Degrees. Okay, so this is basically asking the same question as what this one was, is what's the angle in degrees when the ratio is 1 to 2? So if I was to do that, I could take out the calculator, and I need to make sure I'm in degree mode because I'm doing a degree problem. And I would type in by pressing second sine, 1 over 2. And out should come the angle. And sure enough, it comes out as 30 degrees. Okay, but that I only got one angle here. Instead, back here I saw two different answers. So I'm going to type it in again to get the second answer. Wait a minute, it's still 30. Let me try it again. What the heck? What? Dang it! What's happening? Well, here's an issue here. Why won't the calculator give me the other answer? Why won't it give me 150? Or in fact, why wouldn't it give me all the solutions, like all of the answers by adding 360 to it? The reason is because a calculator it's a function. That means just like a function in math, like a graph, that when you input an x, only one y value can come out. Otherwise, it wouldn't pass the vertical line test. So I can't get a second answer in my calculator because this is called the inverse here, but the key word here is it's an inverse function. And so it can only give out one y value, one answer. I guess you might be wondering, why am I saying y value and that's an x? Well, I just used the variable x, but technically the output is always a y value. So this situation leads us to what we need to talk about today, and that is we're working with inverses today. Our lesson is on inverses, but we need to understand that even though this question looks like it's asking the same thing here, we can only get one answer out of every time we do an inverse. We cannot get multiple answers because this is a function. I don't need to do a third problem here. So hopefully that makes sense, the difference between the two questions here. This one has infinite answers, same question as it being asked here, but because it's an inverse function, we only can get one answer always. Let's talk now on the next video on how we determine what answer comes out.